Deep in the frozen expanse beyond Neptune, where sunlight fades to a whisper and darkness reigns absolute, something has been waiting. Not for years, not for decades, but perhaps for millennia. An object we now call Oumuamua 7, drifting through the cosmic void with the patience of eternity itself. Scientists initially cataloged it as just another chunk of primordial ice, a relic from the solar system's violent birth. They were catastrophically wrong. On September 18th, at precisely 3:47 a.m. Greenwich Mean Time, every major radio telescope on Earth recorded the same impossible event, a signal. Not the random static of cosmic background radiation, not the predictable pulse of a neutron star, but a structured, coherent transmission emanating from Oumuamua 7 with such clarity and power that it temporarily overwhelmed our receivers. For exactly 17 seconds, the object screamed into the void. And then, as suddenly as it began, it fell silent again. But here's what should terrify you. When cryptographers analyzed the signal's mathematical structure, they found something that shouldn't exist. Embedded within the transmission was a prime number sequence so complex that our most advanced quantum computers would need centuries to generate it. Yet this ancient wanderer, supposedly nothing more than frozen rock and gas, broadcast it in less than 20 seconds. The implications are staggering. Either we've discovered a natural phenomenon that rewrites information theory, or something out there wants us to know it's watching. This is not a drill. This is not speculation. This is the story of how humanity's understanding of the cosmos shattered in a single night, and how the pieces refuse to fit back together. For generations, astronomers have understood comets as predictable entities. They arrive on schedule, they brighten as expected, they fade according to established models. The mathematics of their behavior is so reliable that scientists can forecast their paths decades in advance. Comets are, in essence, the clockwork mechanisms of the solar system, elegant in their simplicity, comforting in their consistency. Oumuamua 7 destroyed that comfort with surgical precision. When it first entered the range of our long-distance observation platforms, everything seemed normal. The object measured approximately 4 kilometers across, composed primarily of water, ice, and silicate dust, typical of Kuiper Belt objects. Its trajectory followed a hyperbolic path, indicating it originated from beyond our solar system. Researchers predicted its behavior with confidence, publishing papers that mapped its expected brightness curve with mathematical certainty. Then reality diverged from theory in ways that made no sense. Instead of gradually brightening as solar radiation sublimated its icy surface, Oumuamua 7 remained stubbornly dark. Too dark. Spectroscopic analysis revealed that its surface was absorbing over 98% of incident light, a figure so extreme that it approached the theoretical limits of natural materials. Scientists scrambled for explanations. Perhaps the surface was coated in complex organic molecules, they suggested. Perhaps it had accumulated a layer of ultra-dark interstellar dust during its journey. But then came the flares. Without warning, without any correlation to solar activity or orbital position, the object would suddenly blaze with luminosity equivalent to a major solar flare. These outbursts lasted anywhere from 30 seconds to 3 minutes, then ceased as abruptly as they began. The energy output during these events was staggering, incompatible with any known comet chemistry. Dr. Mikhail Petrov at the Zelenchikskaya Observatory in Russia was the first to notice the pattern. The flares weren't random. They occurred in clusters, separated by precise intervals of 6 hours, 43 minutes, and 18 seconds. That level of periodicity doesn't happen in nature. Chemical reactions respond to temperature and pressure, not to clocks. Only systems with internal regulation with feedback mechanisms, with something approaching intentionality, maintain such rigid timing. What we're observing is either a completely unknown physical phenomenon, Petrov wrote in a classified memo that was subsequently leaked, or we're watching something that possesses, for lack of a better term, a heartbeat. The scientific community divided sharply. conservative astronomers insisted on natural explanations, proposing increasingly exotic mechanisms involving subsurface chemical reactions, tidal heating from interactions with our sun's magnetic field, or resonance effects from trace radioactive materials. But with each new observation, these explanations strained further against the data. Then came the spectrum analysis that changed everything. When researchers examined the light emitted during the flares, they discovered emission lines that matched no known element or compound. The wavelengths were wrong, the intensity ratios were impossible, and the Doppler shifts suggested the emitting material was moving in coordinated patterns at speeds that should have torn any solid structure apart. Dr. Jennifer Walsh, a spectrometry expert at Caltech, ran the analysis 7 times, convinced her equipment had malfunctioned. It hadn't. This is like finding a song encoded in static, she explained in an emergency briefing to NASA administrators. The patterns have structure, they have rhythm, and they repeat with variations that suggest information content. I don't know what we're looking at, but it's not random chemistry. The object's behavior became more disturbing as it approached the inner solar system. Its rotation, which should have been chaotic after billions of years of collisions and gravitational perturbations, was instead perfectly stable. It spun on a single axis with a period of exactly 8 hours, maintaining this orientation with a precision that suggested active stabilization. Amateur astronomers worldwide, coordinating through online forums, began continuous monitoring campaigns. What they documented raised questions that professional scientists were reluctant to voice publicly. The object's rotation aligned perfectly with the ecliptic plane, meaning it was spinning in the same orientation as the planets orbit the Sun. The statistical probability of this occurring by chance was vanishingly small. More troubling still, observers noted that the bright spots on Oumuamua 7's surface, visible during its flare events, seemed to migrate across the object's face in patterns that didn't match simple rotation. It was as if structures beneath the surface were moving, repositioning themselves, perhaps even communicating with each other. Dr. Hassan al-Rusheed, a physicist specializing in complex systems at Cambridge, proposed a hypothesis that earned him both ridicule and a sudden influx of research funding. What if we're not looking at a comet at all? He suggested. What if this is a technological construct so old that cosmic dust and ice have accumulated on its surface, creating the illusion of a natural object? It would explain the absorption spectrum, the controlled energy releases, and the precision of its movements. The idea seemed absurd until researchers began examining historical records. Ancient Chinese astronomers had documented a dark star that appeared in the sky during the Han Dynasty, behaving in ways that defied explanation. Babylonian tablets described a celestial object that pulsed with inner fire and followed, a path that priests interpreted as a message from the gods. Medieval European chronicles mentioned a wandering darkness that appeared every few centuries, always in the same region of the sky. Could Oumuamua 7 be returning? Had it been visiting our solar system throughout human history, each time retreating back into the interstellar darkness before modern science could document it? The implications were staggering. If true, humanity had been observed for thousands of years without knowing it. The composition analysis only deepened the mystery. Standard comets consist primarily of water ice, with smaller amounts of frozen carbon dioxide, methane, and ammonia. Oumuamua 7's spectrum showed something radically different. The primary constituent appeared to be a form of crystalline carbon. It's organized in structures that resembled synthetic materials more than natural minerals. Dr. Yuki Tanaka, a materials scientist at Tokyo University, examined the spectroscopic data with growing disbelief. These carbon structures show chirality patterns that are statistically improbable in natural formation, she reported. It's like finding a sculpture in a rock face. Yes, erosion can create interesting shapes, but there's a point where coincidence becomes implausible. The nitrogen-to-oxygen ratio was equally bizarre. In our solar system, these elements appear in consistent proportions determined by the conditions of stellar nucleosynthesis. But Oumuamua 7 showed nitrogen enrichment that suggested either formation in a completely alien stellar environment or deliberate isotope separation. Both possibilities were unsettling. Trace element analysis revealed the presence of technetium, a radioactive element that doesn't occur naturally, because all its isotopes have half-lives shorter than the age of the solar system. Technetium only exists as a byproduct of nuclear reactions or in the hearts of dying stars. Finding it in a comet was impossible. Finding it in concentrations high enough to detect from Earth was beyond impossible. There are only three explanations, noted Dr. Robert Chen, a nuclear chemist at MIT. Either this object recently passed through a supernova remnant and somehow survived, which violates everything we know about astrophysics, or it formed around a neutron star, which also makes no sense given its trajectory, or something manufactured those isotopes deliberately and placed them there. The third option, the one scientists whispered about but dared not publish, was that Oumuamua 7 carried the decay signatures of ancient nuclear processes that might power something far older and more sophisticated than human technology. Then came the radio signal, and speculation transformed into crisis. The transmission lasted exactly 17 seconds, but those 17 seconds contained more information than humanity broadcasts in a year. Every radio telescope capable of operating in the relevant frequency range recorded it simultaneously. From Arecibo's successor facility in Puerto Rico to the square-kilometer array in South Africa to the FAST telescope in China. The signal's power output was staggering. To generate a transmission that's strong from such a small object would require an energy source orders of magnitude more efficient than anything in our technological arsenal. It was equivalent to focusing the entire electrical output of a major city into a single coherent beam. But the real revelation came when researchers analyzed the signal's structure. It wasn't noise, it wasn't random, it was mathematics. The transmission began with a series of pulses representing prime numbers: 2, 3, 5, 7, 11, 13, and so on, establishing a basic mathematical framework. This was followed by more complex sequences, Fibonacci numbers, perfect squares, and then patterns that seemed to represent geometric relationships: circles, triangles, three-dimensional structures. Dr. Elena Rodriguez, mathematician specializing in information theory at Princeton, led the decryption effort. What her team discovered made international headlines for approximately 6 hours before various governments requested a media blackout. The signal contains what we can only describe as a star map, Rodriguez explained in a hastily convened press conference before the shutdown. It shows the relative positions of nearby stars, including Sol, our sun. But here's what's disturbing. The positions shown aren't current, they're dated, based on stellar proper motion calculations. The map shows the sky as it would have appeared approximately 12,000 years ago. 12,000 years. When human civilization was just emerging from the last ice age, when our ancestors were building the first permanent settlements, developing agriculture, creating the foundations of recorded history. The implications hit the scientific community like a physical blow. Either Oumuamua 7 had been watching us since before the pyramids, before writing, before cities, or the signal was a recording. A message in a bottle left by something that passed through our solar system at the dawn of human civilization. But the signal contained more than just a star map. Embedded within the mathematical sequences were patterns that appeared to represent complex chemical formulas, including the basic structure of DNA. Not human DNA specifically, but the fundamental double helix configuration that carries genetic information. It's like they're showing us a universal framework for life, noted Dr. Sarah Mitchell, a biochemist at Stanford. As if they're saying, we understand what you are, we recognize the pattern, we know you're alive. The signal ended with a sequence that cryptographers and linguists are still debating. A series of pulses that might represent coordinates or time intervals, or perhaps even instructions, But the final element was unmistakable. A countdown, numbers descending in a clear mathematical progression, ending with 0. 0, silence, and then nothing. The question that keeps scientists awake at night is simple and terrifying. Countdown to what? The trajectory of Oumuamua 7 became the focus of intense scrutiny. Using data from multiple observatories, astronomers reconstructed its path through our solar system with unprecedented precision. What they found was disturbingly elegant. The object had entered our solar system from the direction of Epsilon Eridani, a star system just over 10 light-years away that we know contains at least one gas giant planet and possibly several terrestrial worlds. Its angle of approach was nearly perfect for a gravity-assisted tour of our planetary neighbors. First, it had passed within 3 million miles of Neptune, using the ice giant's gravity to adjust its trajectory. Then it swung past Uranus at an optimal angle for another gravitational boost. It skimmed Saturn's orbit with mathematical precision, arriving just weeks after the ringed planet had passed that point in its orbit, avoiding any interference while still gaining momentum. Now it was heading toward Jupiter, set to arrive within 28 million miles of the gas giant on December 15, 2025. The timing was extraordinary. Jupiter would be in perfect position for detailed observation from Mars and Earth. Multiple space missions, including the Europa Clipper and JUICE spacecraft, would have optimal viewing angles. Dr. Marcus Webb, an orbital dynamics specialist at ESA, ran the calculations and came to an uncomfortable conclusion. If you wanted to design a trajectory that maximized observational opportunities of our major planets while minimizing detection time and travel duration, this is exactly the path you would choose. Every gravity assist is optimized. Every approach angle is calculated for maximum data gathering with minimum energy expenditure. The efficiency was almost insulting. Here, humanity struggled with complex orbital mechanics, burning precious fuel for every trajectory adjustment. And Oumuamua 7 was executing a grand tour with the grace of a ballet dancer. More disturbing was what came next. After Jupiter, orbital projections showed the object would perform a sharp trajectory change, something that should require a significant energy expenditure. But there was no sign of the massive outgassing event that would be necessary for such a maneuver. No comet had ever performed such a radical course correction without dramatically altering its appearance and composition. Natural comets don't change direction like that, explained Dr. Jennifer Park, a comet specialist at Lowell Observatory. It's physically possible only if something is providing directed thrust. Either this object has some kind of propulsion system, or we're about to witness the most violent outgassing event in recorded history. Amateur astronomers began placing bets on which scenario would prove correct. Professional scientists quietly hoped for outgassing while preparing papers on propulsion mechanics. The object's final trajectory, assuming it completed its projected course change, would take it past Mars at a distance of just 9 million miles. Close enough for extraordinary observation, but far enough to avoid any risk of collision or atmospheric capture. Then it would execute one final gravity assist from Earth itself, using our planet's momentum to slingshot back toward interstellar space. But here's what made researchers genuinely nervous. The timing of the Earth flyby, scheduled for March 2026, would occur during a rare alignment of Mars, Earth, and Venus. All three terrestrial planets would be positioned for optimal observation from Oumuamua 7's trajectory. The statistical probability of this occurring by chance was less than 1 in 100,000. Dr. Avi Loeb, the controversial Harvard astrophysicist who had proposed that the interstellar object Oumuamua might be artificial, weighed in on Oumuamua 7 with characteristic boldness. We need to consider the possibility that we're watching an automated reconnaissance mission, he stated in a widely shared interview. If an advanced civilization wanted to survey our solar system efficiently, this is precisely the trajectory they would design. Every major planet observed, multiple terrestrial worlds studied, maximum scientific return with minimum energy investment. The comparison to Oumuamua was inevitable. That earlier visitor had also shown unusual properties, an unexplained acceleration, an elongated shape unlike typical asteroids, and a trajectory that suggested non-gravitational forces at work. Loeb had proposed it might be a light sail, a theory that earned him both admiration and criticism from colleagues. But Oumuamua 7 was different. Where Oumuamua had been silent and inert, this new visitor was actively transmitting. Where Oumuamua had tumbled chaotically through space, Oumuamua 7 maintained perfect rotational stability. Where Oumuamua had been small and light, Oumuamua 7 was massive and dense. If Oumuamua was a scout, Loeb suggested, then Oumuamua 7 might be the main survey vessel, the one that comes after the preliminary reconnaissance to gather detailed data. The thought was simultaneously thrilling and terrifying. Thrilling because it would confirm we're not alone in the universe. Terrifying because it would mean we've been observed, studied, cataloged without our knowledge or consent. Behind closed doors, military strategists and government officials were having very different conversations. If this was technology, what did it reveal about the capabilities of its creators? What could we learn from it? And perhaps most urgently, what were they learning about us? The decision was made quickly and quietly. Multiple space agencies would coordinate an unprecedented observation campaign during the Jupiter encounter. Every available telescope, from ground-based observatories to space-based platforms, would focus on Oumuamua 7. High-resolution, imaging, spectroscopy, radio monitoring, everything. NASA's James Webb Space Telescope was retasked from its planned observations. The European Space Agency's GAIA mission, designed to map the positions and motions of stars, turned its precise instruments toward the visitor. Even private space companies like SpaceX and Blue Origin offered their satellite networks for continuous monitoring. "We may never get another opportunity like this," noted NASA Administrator Dr. Patricia Reyes in an internal memo. "Whatever this object is, we need to document everything about it. Because if it leaves our solar system, we may not see it again for thousands of years, if ever." There was also the uncomfortable possibility that Oumuamua 7 might not leave. If it was capable of directed thrust, it could potentially enter orbit around one of our planets. Or worse, it could decelerate and settle into a permanent position in our solar system, observing us indefinitely. Dr. Thomas Drake, a former NSA analyst turned space policy expert, raised an even more disturbing scenario. What if the signal was a message to something else? What if Oumuamua 7 was reporting back, telling something out there that we're here, that we're technological, that we're worth investigating further? The thought of Earth's position being broadcast to unknown intelligences was unsettling. But then again, humanity had been inadvertently broadcasting our presence for over a century through radio and television signals. If anyone was listening within 100 light-years, they already knew we were here. The color changes observed in Oumuamua 7 provided another layer of mystery. Unlike typical comets that maintain relatively consistent coloration, this object cycled through distinct hues over time. First observed as a dull reddish-brown, it had shifted to a striking blue-green, then to an almost metallic silver, before settling into its current deep black appearance. Dr. Lisa Chen, an expert in planetary atmospheres at UC Berkeley, proposed that the color changes might be related to surface transformations. If this object has a complex surface chemistry, perhaps reactive materials that change state in response to solar radiation, that could explain the color shifts, she suggested. But the timing of the changes didn't correlate with distance from the sun or any other obvious environmental factor. Instead, they seemed to occur at regular intervals, almost like a display changing through different modes. It reminds me of chameleon skin. Noted biologist Dr. Marcus Williams consulted for his expertise in adaptive coloration. Organisms change color for specific purposes: camouflage, communication, temperature regulation. If this object is changing color deliberately, we have to ask, for what purpose? Is it responding to different wavelengths of solar radiation to maximize energy absorption? Or is it signaling? The possibility that the color changes themselves might be a form of communication sparked intense debate. Some researchers began analyzing the timing and duration of each color phase, looking for patterns, mathematical sequences, anything that might suggest intentional signaling. What they found was troubling. The duration of each color phase, measured in hours, corresponded roughly to the orbital periods of planets in our solar system. The red phase lasted approximately 24 hours, matching Earth's rotation. The blue phase lasted about 10 hours, close to Jupiter's rotation. The silver phase matched Mars. Either this is the most extraordinary coincidence in the history of astronomy, noted Dr. Raymond Foster, or something is deliberately showing us that it understands our solar system's architecture. The object's thermal signature added another puzzle. Infrared observations revealed that Oumuamua 7 maintained a remarkably consistent temperature despite varying distance from the Sun. Most objects in space experience dramatic temperature swings based on solar exposure. Comets, in particular, show extreme variations between their sun-facing and dark sides. But Oumuamua 7's surface temperature remains steady at approximately -43 degrees Celsius, regardless of orientation or solar distance. This suggested either an internal heat source or an extremely efficient heat distribution system, neither of which should exist in a natural comet. That level of thermal stability requires active regulation, explained Dr. Angela Martinez, a thermal engineer at JPL. In our spacecraft, we achieve it through complex insulation systems, radiators, and sometimes active heating elements. For a natural object to maintain such stability would require properties we've never observed in any celestial body. The heat signature also showed subtle patterns. Small regions of the surface periodically became slightly warmer than their surroundings, creating thermal hotspots that appeared and disappeared over time. These spots weren't random. They formed geometric patterns, lines, and triangles that shifted across the object's surface. When researchers mapped these patterns over time, they discovered something extraordinary. The thermal hotspots appeared to be tracing out constellations, familiar star patterns as seen from Earth's perspective. Orion, Ursa Major, Cassiopeia. One after another, the surface of Oumuamua 7 was drawing pictures of our night sky. It's like someone showing us flashcards, Dr. Chen observed with barely concealed wonder. Here's what we see. Here's what we recognize. Here's how we perceive your celestial sphere. The magnetic field measurements were equally bizarre. Natural comets typically have weak, chaotic magnetic fields generated by the interaction of solar wind with ionized gases. Oumuamua 7 possessed a strong, organized magnetic field with a structure that resembled a miniature magnetosphere, complete with distinct poles and radiation belts. Dr. Yuki Tanaka, a magnetospheric physicist, was stunned by the readings. This field strength is orders of magnitude higher than it should be, and the configuration is too perfect. It's like looking at Earth's magnetic field in miniature, but there's no dynamo mechanism that could generate it. No rotating iron core, no convection currents. The field is just there, stable and strong, with no obvious source. More remarkable was how the magnetic field interacted with the solar wind. Instead of being buffeted and distorted as expected, Oumuamua 7's magnetic field appeared to actively shape the incoming charged particles, channeling them into specific patterns that created auroral displays, stunning light shows in the gases surrounding the object. These auroras weren't random. They pulsed in patterns that matched the prime number sequence from the radio transmission. The object was, quite literally, painting mathematics in light across the surface of space. As December 15th approaches, the date of the Jupiter encounter, tension builds in the scientific community. Multiple scenarios have been prepared. If Oumuamua 7 behaves as a natural comet, it will pass Jupiter without incident, perhaps brightening slightly from the planet's reflected light. If it's something more, if it possesses capabilities beyond the natural, then the encounter might reveal them. Jupiter's intense magnetic field and radiation environment will provide a stress test. Natural objects can't survive long in that harsh environment without being torn apart or dramatically altered. But a technological construct, properly shielded, might pass through unaffected. Think of it as the ultimate reveal, suggested Dr. Loeb in a recent interview. Either the mask comes off, or we confirm it's just an unusual rock. Either way, we'll finally have our answer. But there's a third possibility that keeps researchers awake at night. What if Oumuamua 7 does something unexpected? What if it transmits again? This time, a longer, more detailed message. What if it releases smaller objects, autonomous probes that scatter across the solar system? What if it stops? The James Webb Space Telescope has been positioned to capture the encounter in unprecedented detail. Its infrared instruments will penetrate any dust or gas surrounding the object, revealing surface features with clarity never before achieved. If there are structures, if there are signs of artificiality, Webb will see them. Ground-based observatories have organized a global watch network. Professional and amateur astronomers alike will maintain continuous observation throughout the encounter. The data will be shared in real time, creating a distributed network that no government can control or censor. This is bigger than national security, argued Dr. Sarah Mitchell at a recent international conference. This is about humanity's place in the cosmos. If there's evidence of non-human intelligence out there, everyone deserves to know, not just government officials and military strategists. The debate over disclosure has become fierce. Some argue that conclusive evidence of alien technology would cause worldwide panic, destabilizing governments and economies. Others contend that humanity has a right to know the truth, whatever it might be, but perhaps the decision won't be left to human authorities. If Oumuamua 7 transmits again, if it makes its nature undeniably clear, there will be no hiding the truth. The cosmic secret will reveal itself whether we're ready or not. Dr. Marcus Webb perhaps put it best during a late-night conversation at an observatory in Chile, words that were recorded and have since spread across the internet. For all of human history, we've been alone in a silent universe, calling out into the darkness with no response. We built radio telescopes and listened to static. We sent probes into space carrying messages we doubted would ever be read. We searched for meaning in a cosmos that seemed indifferent to our existence. But what if the silence was never real? What if we were never alone? What if something has been watching us all along, waiting for us to reach a certain level of development before making contact? What if Oumuamua 7 isn't an intruder, but a messenger, sent by intelligences so far beyond us that we can barely comprehend their methods? In just a few weeks, we may finally know. And that knowledge, whether it confirms our deepest hopes or our darkest fears, will change us forever. Because once you know you're not alone, once you understand that intelligence exists beyond our pale blue dot, you can never go back to thinking of humanity as the center of creation. We become instead what we've always been, but never fully accepted. One small voice in a chorus that spans the stars. The countdown continues. December 15th approaches. And somewhere out there, beyond the orbit of Mars, but not yet reaching Jupiter, Oumuamua 7 continues its silent journey, carrying mysteries that may soon reshape everything we believe about our universe and our place within it. Are we ready for the answer? Whether we are or not, it's coming. The universe is about to speak again. This time, the whole world will be listening.